8th grade lesson 9.5 is congruent figures, and actually what this really is, this lesson is a combination of two things. It is either creating a couple of steps of transformations, maybe 2 or 3 different types of transformations that they guide you through, or recognizing what transformations must have happened in order for an image to become, in order for a pre-image to become the image. And so it's just getting some practice at some of the transformations we've looked at. So let's refresh our memories on those transformations. Okay, so just to refresh our memories of all the transformations, the translations are the ones that slide, and they'll usually tell you which way, over this many, down this many, or over left, 2 left, 3 up, or something like that. Reflections fold across an axis. So it's a reflection across the x-axis, so that x-axis is the folding mark, or a reflection across the y-axis, where the y number line is the one we're folding. Rotations turn 90 degrees clockwise or 90 degrees counterclockwise. And then just keep in mind, congruent means same size and shape. That's the little symbol for congruent. And so any of these transformations that we do, we're not changing the size or the shape of the figures or of the pre-image. We're only changing the direction they're facing or where they are at on the coordinate plane. But the size and shape remains the same. So the image will be congruent with the pre-image, same size and same shape, still just facing in a different direction. So let's have a look. In our Explore activity, they ask us to combine several transformations. So we'll just go one step at a time. The first one they want us to do is do a reflection across the x-axis. So this item is going to be folded on the x-axis and end up over here. So I'm just going to choose my points. This is 2 away here, so it will be 2 away there. And then 2 down. And then from the top mark, it is 2 in. And there's my reflection point. So I just reflected that. That part is done. Then they want me to reflect that image, this one now, across the y-axis. So I'm going to fold that here, and now this one is going to end up over here. It is now 1, 2, 3 away. 1, 2, 3, mark it there. Then 2 more. Then 2 up this way. And there is my reflected across the y-axis. They did give me the algebraic pieces. You could do it either way. Then they want me to rotate 90 degrees clockwise around the origin. And for the rotations, you guys know by now, that's the one that hurts my head. So I flipped to the page in the book that gave me the algebraic representation of a rotation. And I looked at the 90 degree clockwise, and that says multiply your x coordinate by -1. And then flip the 2 coordinates completely around. So I went through and looked at my coordinates. This one was a -5, -2. This multiplied by negative is going to be a positive. And then I just flipped those around. So I will get a -2, 5. This point was -5 on the x, -4 on the x. This multiplied by -1, like it says here, will be +5. And then I just flipped these around, -4, 5. And I did the same for this point. It was -3 on the x, -4 on the y, multiplied by -1, giving me a +3, and then flipped them around. For my new points, I will go ahead and plot these new coordinates. Okay, and there it is rotated. Again, the one that's the hardest for me to visualize, so I have to turn to relying on that algebraic piece. And that's just a matter of knowing what you understand and what you don't. And I know that's my weakness, so I use the algebraic piece to that. That's just easier for me. So they want us to compare the size and shape of the final image, this one, to that of the original figure, this one. And the size and shape of them are the same. There's a length of 2, and then this one crosses 2 diagonals, length of 2, and this one crosses 2 diagonals. So they're the same size and shape. Which transformation change the orientation of the figures and which do not? The orientation is just which way is up or which way is down or which way is side to side. And I'm looking at from here to here, it gets flipped upside down, so that changes in orientation. From here to here, you get it flipped over, it's facing opposite directions. from here to here, it's facing all kinds of different directions. So in my opinion, I believe the answer to that is all of them change the orientation of the figure. And after a series of transformations, two figures have the same size and shape, but different orientations. What does this indicate about transformations? What does it indicate about transformations? Yeah, they stay congruent. They stay the same size and shape, right? They just kind of change their position, I guess. Word it how you want. On the next page, there is a communicate mathematical ideas. It says, how would you find the vertices, one of the points, of an image if a figure were rotated 270 degrees clockwise? Think about that. I'm going to be drawing over here. Let's just use this line. If I'm turning, let's say I start here and I want to go clockwise 90 degrees. Okay. Then another 90 degrees. That's a total of 180 degrees. And then clockwise even more, 9, 18, 27, so 270 degrees is right here. Rather than have to do this little trick 3 times over, why don't we go the opposite direction to end up at that point? So describe what that would mean. That's what that question number 3, just picturing it drawn out would help with that. All right, let's look at a few examples from the guided practice. I take it back. I got ahead of myself. There are some examples. This is, instead of saying you make the translation or the transformations, several different transformations, this one is showing you, this is the second part of this lesson, this one is showing you what two images, a pre-image and an image, and you're trying to identify, well, what transformations would I have to make in order for that image to get where it's at? So if I have a pre-image and then here's my image, I'm assuming alphabetically this is my pre-image, and then there's my image. A couple of things happened for me to get from here to here, and so you ponder over it a little bit, knowing what your transformations are. I have the one that slides, I have the one that reflects, I have the one that rotates. Since this bottom is still this bottom, I don't think I've got a rotation going on. It looks like I almost could have just folded this across. So the only difference is this is further from here. This one's further than this one. So if I were to fold this pre-image across, it would have ended up, this point would be right here. So it would have ended up like this. In fact, I'll draw where it would have ended up. So there in white is where it would have ended up. But it looks like after they did the reflection across the y-axis, then they slid it back by 1. Every point was to the left by 1, and that was a translation. So we have a reflection across the y-axis and a translation to the left 1 spot. So that's how you would describe what happened here. Transformation figure A into figure B, you need to reflect it over the y-axis and then translate 1 unit to the left. And then they say, how would you write that algebraically? So to write that algebraically, now that you know that you have the translation, the reflection over the y-axis, and then translate 1 unit to the left, then you just flip to page 300 where they have the rule on the reflection, and you find the one that says across the y-axis, and you write down that formula they gave you for that, or that set of rules they gave you for that. And then you have the translation piece, so you flip, you're going to the left a certain amount of units, and that written on page 299 for the translation rules, that's what is written there. So you would just write those down. So when they tell you to tell what algebraically happened, and that's what you would put down. I figure I'll show you what I mean first better so you can see it. So this is the chart off of page 299 for the translations. So if I knew it slid back to the left, I should say, by 1 unit, then we went to the left, in this case 1 unit, not A units. And so this is what you're writing down right here. That's what they got. So when it says describe algebraically, you're using these charts to describe. And then this is the same thing that came off the reflection chart. So these, when they say write algebraically, this is the part they mean. So here went right here for the translation. Let's look at this other one. So when you look at that, take a look at what would have happened. Maybe it's just two things that needed to happen. Let's take a look at what would have happened in order to get to this point from point B to point C. And I'll go ahead and pause it and see if you can figure it out. Okay, now that you've unpaused and you think you've got what it's done, you took pre-image B, and notice this is like the bottom of it, the butt of it it's sitting on. But now over here, there's where the butt's at. So it must have rotated, and it rotated counterclockwise. So I have a rotate counterclockwise by 90 degrees. And then if I were to do that though, rotated counterclockwise is going to be right around, okay, so in white is how that rotate counterclockwise 90 degrees ends up. Again, for me, I had to go look up the algebraic piece. This was me working things out to get the coordinates for at least this bottom part. Once I had the bottom part where it belonged, I was able to do the rest visually. So if I just rotate counterclockwise 90 degrees, there I am. But look, I ended up over here, so it looks like I slid this way. So I have a translation of over to the right 1 and up 2. So translate. And now that I know what has happened, when they asked for the algebraic part, I would look up what is a counterclockwise by 90 degrees rotation. That is, I should have made room here. I'll put it in blue and I'll squeeze it in here. That is x, y turns to minus yx, because we multiplied the y by negative, so whatever the opposite of y is. And then this one has a translation. Here's the chart here with the translations. We went right to 1, so right a units means you're adding that whatever number you went right by to the x unit or x coordinate. Up to is here, you're adding whatever the value is to the y. So we would say I take my xy and I do x plus 1 and y plus 2. And that would be the translation to go over 1 up 2. So that's how you write it algebraically. You're going to be flipping back and forth between those pages 299, 300, and 301, I believe, are the pages that have those formulas on them, so that you can explain what happens algebraically. So it's just taking the time to see how did they get from here to here, what 2 or 3 things would they have to have done to get to that point. And that's all this lesson is about. So just kind of take one bite at a time. What's the first step you can take to get there? And then after that, what would you have to done? And you might find it in different orders too than somebody else. That's okay too. So just took a lot of visualization, or take the steps and draw them on there real lightly with pencil to help you out. But I'm sure you'll see things. You'll see most of them just fine.